Hi there, Turgeon here, bringing you physics from afar. Let me help you with the MCAS waves. And this is next generation, meaning closer to the new MCAS as far as 2022 is concerned. This first question has to do with these different types of rays, which, if you remember from electromagnetic rays, these are all types of electromagnetic waves. So we know that all of the electromagnetic waves, we'll learn this more later, but they basically go at the same speeds because wave speed is determined by the medium. In the case of electromagnetic waves, they don't even need a medium, but it's kind of determined by the properties of whatever they're going through. In the case of electromagnetic waves, that can be space itself. But we know these are all going at the same speed, the same as visible light. But even if you didn't know that, you could look at the values. So frequency and wavelength, the velocity is frequency times wavelength. So if you multiply 10 to the 20th, if you multiply each of these 3 times 10 to the 20th, 1 times 10 to the negative 12, you're going to get the same number for the wave speed for all of these. Also, look at these choices. Same period, all the frequencies are different, therefore the periods must be different. All traveling in a solid, I mean, there's no indication of that. I mean, they could be, but that's not likely. And you certainly couldn't conclude that from these random numbers. And that they have the same amplitude, this doesn't tell us anything about amplitude. The frequency doesn't tell us how much energy is in the wave. When you get to number 2, you can see the word sonic. Whenever you think of the word sonic, think sound. So you know that these are some kind of longitudinal wave because they're sound. And ultra means high frequency, so it's not going to be low frequency. But the big key here is look at this vibration and how it's in the same line with the wave velocity. That's longitudinal. The vibration and the velocity are parallel. Part A for question 3. It's just just using V equals lambda F. So straight up put the numbers in. Boom, boom. I mean, what do I do here to get 10.44? Well, V is 4176. Lambda, the upside down Y thing, that's wavelength. We don't know that. F is 400. And now to get lambda alone, I'm going to divide both sides by 400. You get 10.44. They didn't really give you choices here, but you just write whatever you can. So sound waves travel through air at a speed slower than the speed they travel through brick. Why? Because we know that sound goes fastest through solids, slowest through gases. Then they ask you to say something about the wavelength, and the wavelength is going to be shorter, and I'll prove that right here. If the you can just look at the equation, you can see that for the same frequency, if the speed is slower, the wavelength must be lower, lambda. But if you plug the numbers in, if you remember that the speed of sound in air was about 340, 350, then you can plug that in. We did this thing with wave interference, and what happens is as the waves come toward each other, not the wavelengths, not the frequencies, but the amplitudes get larger. The amplitudes get larger. So as the waves approach, they get taller. For a split second, they overlap and all the energy is contained in this one wave. Then you can see afterward they go about their business. So remember, when there's wave interference, that means two waves are kind of occupying the same space at the same time. The amplitude is affected, not the wavelength. This has been Physics from Afar.